Hi, good day my dear grade 11 students. So how are today? I'm hoping that all of you are doing fine and safe at home. So for now, we're going to discuss about applied problems involving sampling distribution of sample means. The central limit theorem assumes that the sampling distribution of the sample means will tend to have a normal distribution regardless of the shape of the population. Let us have some examples. Let us have these examples. A population of size of 350 has a mean and a standard deviation of 14. What is the probability that a random sample of size is equals into 40 will have a mean of 80 or more? In this problem, the population is definite because its size is given. We shall use the normal distribution as our mathematical model for the sampling distribution of sample means as assured by the central limit theorem. For our step 1, so we are going to use the fact from the central limit theorem, wherein we are going to use this given formula of our given to convert the values for the z-score. In our given problem, so our given are, so for our population size is 350, our mean is 75, our standard deviation is 14, our sample size is 40, and the value of our x is equals into 80. Okay class, let us first find for the variance of the sampling distribution of the sample mean using this given formula. So let us substitute for the given value. So of course, we all know that the value of our standard deviation is equivalent into 14. All over the square root of our sample size, which is 40, to be multiplied by the square root, okay, by the square root of our population size, which is 350, minus, of course, our sample size, which is 40, all over, of course, our population size, which is 350, minus 1. Okay, class, so let us solve for our given. So, you need first to have here 14, okay, all over. So we have here the square root of 40, which is equivalent to 6.3245 or 325, to be multiplied by, of course, do not forget, the square root of 350 minus 40, so we have 310, all over 350 minus 1 is 349. Now class, so if you have 14 over 6.325 times the square root of 310 over 349 using your scientific calculator, so divide this, so you have 2.213 at least 3 decimal places, to be multiplied by this square root, so you have 0.9425. So if you multiply 2.213 times 0.9425, so you have 2.0862. So from 2.0862 or 2.09. Now class, after you find for the standard deviation of the sampling distribution of the sample mean, let's proceed into conversion of our mean, wherein we have 80 to z-score. Use the formula, z-score is equals into the mean minus the population mean all over the standard deviation of the sampling distribution of our sample mean. So let's substitute. So our given is 80 minus, of course, our population mean given earlier is 75 all over the value that we have obtained in finding for the standard deviation, wherein we find as 2.09. So let us have here 5 to be divided by 2.09. So to find for the z-score. So let us have here, so we have, or we need to divide 5 by 2.09, and that is equivalent to 2.39. So therefore, our z-score is equals into 2.39. Class, for our step 2, so we want to get the probability that a random sample size of 40 will have a mean of 80 or more. So that is, we shall find for the probability of our mean is greater than or equals into 80. So using the table for areas of the normal distribution, so we come up in this. So if you are going to draw or sketch this, so this will be the sketch. So you have here the greater, or we'll have 2.39 or more. So we are finding for this probability. So we have here the probability of the mean is greater than or equals into 80 is equals, of course, into the probability of the standard score is greater than or equals into 2.39. So we have here the probability of the standard score is greater than or equals to 0 minus, of course, the probability wherein the z-score is, of course, greater than or equals to 0, but of course it is greater than or equals into 2.39. So we have here 0.500 because we all know that the half of our area is 0.5. So minus the value of 2.39 using the table of the areas under the normal distribution, which is 0.4916. So if you're going to subtract these, so we have here 0.0084. So Thus, the probability that a random sample size of 40 will have a mean of 80 or more is 0.0084. Okay, class, let us have another example. For example, we have here the given population size as 95, sample size is 38, population mean is 115, population standard deviation is 3.23, and the given probability of our mean is greater than 114 but less than 114.5. So let us find for this situation. For the first step, we need to convert the values to standard scores or the z-score. First thing that you're going to do is to find for the standard deviation of the sampling distribution of the sample mean, and then we need to convert our given mean into the z-score. So let's solve for this. Okay, class, so let us find for the standard deviation of the sampling distribution of the sample mean using our given. So let us have here now the standard deviation of the sampling distribution of the sample mean using the formula. So we have here the standard deviation all over the square root of our sample size to be multiplied by the square root of our population size minus our sample size all over our population size minus 1. So let's substitute. So we have here 3.23 all over, so the square root of 38 to be multiplied by, of course, our square root of 95 minus 38 over 95 minus 1. So we have now here, so 3.23 divided by square root of 38 is equals into 0.523975 to be multiplied by the square root of 95 minus 38 all over square root of 95 minus 1. So we have here the square root of 57 all over 94. So we have here now 0.523975 to be multiplied by the square root of 57 over 94 is equivalent into the square root of 0.60638. And then the next thing that we are going to do after that is we are going to solve for this. So we have here now 0.523975 to be multiplied by the square root of this as 0.77871. And then after that, we are going to multiply the two numbers as 0.523975 times 0.77871. So we have here 0.4080. Or of course, so we have here now as our equivalent as 0.41. Okay, so this will be our standard deviation of the sampling distribution. The next thing that you are going to do is you are going to convert for, of course, our mean is equivalent into 114 into z-score. So that will be the next thing that you're going to do. So we have here z-score is equals into 114 minus 115 all over 0.41. And then, of course, so 114 minus 115, that is equivalent into negative 1 all over 0.41. Then, let us divide 1 by 0.40. So, this is equivalent into negative 2.43. Okay? Then, the next thing that you are going to do is we are going to have the second one. Let us convert, of course, our mean is equals into 114.5 to z-score. Okay? Then we have here z-score is equivalent into 114.5 minus 115 all over 0.41. So we have here 114.5 minus 115. That is negative 0.5. Okay, so we have negative 0.5 to be divided by 0.41. So we have here negative 1.22. Okay, so that will be our answer. So negative 1.22. Okay, for step 2, we need to get the probability that the random sample size of 114 will have, or 115 will have a mean of between 114 and 114.5. So that is, we are going to use the probability of course, we have the mean is greater than 114 but less than 114.5. So in this case, we are going to use the table of areas under the normal curve. So we all know that if we are going to sketch, so we are going to sketch the area under the normal curve. So we have here, of course, so we have here 0. And then, of course, this will be negative 1.25 Okay, 1.25. And then, of course, this will be negative 2.43. So, we are finding for this part or for this probability. Okay, so we are finding for this probability. And then, class, after that, of course, we're going to use the probability of course, our, we have here the mean as greater than 114, but of course, it is less than 114.5. So, we have here now the probability of our standard score is greater than negative 2 point, of course, 43, but of course, this is less than negative 1.25. Okay, so we have here now the probability of negative 2.43, but of course, so we have here greater than but less than 0 minus the probability, of course, of 0. Then, of course, so we have here negative 1.25. And then use the table of the normal distribution. Let's find. So we have here 2.43 as 0.4925 minus 1.25 as 0.3888. Then let's subtract this. So we have 0.1037, or of course, so we have 10.37%. So this will be our answer. So therefore, we can say that thus, of course, do not forget your final answer. The probability, okay, the probability that a random sample size n, of course, our n as 38, and then of course, we'll have a mean between, of course, so we have between our given as 114 and 114.5. So we have here is we have 0.1037, or so we have here 10.37%. So that will be our final answer. Okay, class, so that would be all for today. Those are God bless everyone. Stay safe.